Today we're looking at section 1.4, trinomial factoring when a does not equal 1. We have a coefficient out in front. That's all it means. Yesterday they were all x squared. Today we have numbers out in front. So, could you factor that? What would you do? You'd wait for me to tell you. Try again. Okay, factor out of 2. Okay, let's do that. Okay, does that solve our problem? No coefficient, right? So now to factor it, what am I going to do? What did we look at yesterday with the 5 and the 4? Which are? 4 and 1. So we go x plus 4, x plus 1. So we could use that greatest common factor to help us out. Not all of them will work this way. It's nice when you can factor something out, it turns into this nicer form. I'll give you this problem later today after we talk about using this method, or if it doesn't factor, we're going to prefer factoring, get down so there's a no coefficient, it's just an x squared. This works nicer. Now what we need to be aware of is what if we had something that looks like that. We hopefully look at it. Can we factor out of 2? We can't. 13 and 15 are odd. So what I want you to do is I want you to draw the box. And I want to think about if we started with or ended with 2x squared plus 13x plus 15, how can you fill it in and work your way back to it? So where can we put something? We want to put here. Okay? Top left? Okay? Now, not sure about the 13x, but I know at least one of these will be 2x and one of these will be x. You agree? Okay? So now I got to find a way to get that sum of 13. Well, looking at 13, there's no factors of 15 that add to 13. We get that 2 involved. But let's just think about 15. What would you try to multiply to get 15? 3 and 5. So let's put one right here and one right here. Now the 2 is going to affect that diagonal that's not filled in. But 3 and 5 are good places to start. So if I did that, I would now have 6x and 5x. Does that work? Okay, let's switch them. So now I have a 10x and a 3x. Does that work? 13, it worked. So I'm looking at 2x plus 3 and x plus 5. Okay, it factored down. Now, this is kind of a guess and check method. Now, a lot of this we see today, there's going to be a little bit of guess and check involved. There's not a quick pattern that we automatically find them. How many have seen this factor before? I mean, it's hard to say with your classes that, changing over. Have factored these? None yet? And you use that diamond that looks like an X method? Fantastic. Teach you the right way to begin with. All right. So that's our goal to factor it. That would require some guess and check. We look at some factors, try to figure out where that 2 fits in nicely to solve. Let's look at another one. Okay, start to take this one apart and see what we get to. So as we're looking at, what's one thing we can get out of the way to start? Factor out 2? Makes numbers smaller, easier to work with. Sounds good to me. All right, so let's say I'm looking up here, I got the 2x squared. What's one of these terms going to be on the top? 2x and x, right? We're not going to make both of them 2x. We make either one there. Now, we're looking at factors of 16. To finish out each of them, downside about 16 is we got 1 and 16, 2 and 8, and 4 and 4. Which ones do you want to try? 1 and 16? I'm going to put 1 there, 16 there? Or switch? So we want to go 16 and 1? All right. So I got 32x, negative x, it combines. So now it came out to be 2. Don't forget to bring down the 2. 2x minus 1, x plus 16. Now this is where we start to see it requires some guess and check. It's a puzzle. You got to take it apart, figuring out your adding, your multiplying. It's just kind of a little bit more of a level than we saw yesterday when we didn't have that coefficient out in front. There's multiple things at play here because you particularly have a number out in front of an x, or 2, which we'll see later. Okay? I'm going to show you a different method, something that works for us. If you look up factoring trinomials, especially when there's a value out in front of the coefficient, there's a variety of methods. I'll show you one today. That's an option compared to this. I'll show you another one on probably Friday that relates to what we do there. You find what works best for you. Okay, why I asked if you guys have seen it before is sometimes that first method you saw maybe back in middle school is the one you stick with. Find the method that works for you. You want to get to the answer. So I'm going to take this 2x squared part that I already factored out. And this is what we call the Berry method. So I know when I factor this, it's going to end up to be 2 binomials. So what I want to do is I'm going to put the x's down. We know from the left side that one of them is going to be 2. I'm going to make both of them 2. Now, I'm going to look at, let me get space here, taking negative 16 times negative 2, or negative 16 times 2, gives me negative 32. And I have 31. I need to find what multiplies to negative 32 that adds to 31. Kind of goes back to yesterday. What would I use? Multiplies to negative 32, adds to 31. Okay, so we'll put 32 and negative 1. But can I simplify one of those? Yeah. I'm going to make the one on the left x plus 16. Same answer? Well, we bring over the 2, obviously, that I factored out at the beginning. But same answers I had, right? Okay, doing this process automatically lets you determine your lead coefficients and then factoring down. Really, it's that what multiplies, what adds to, we saw yesterday. Let's go back to the first one we did. Or the second one we did. Let's take the 2x squared plus 13x plus 15 and try it there. So for this, using the Berry method, I'm going to make both of them 2x. So I'm going to multiply to equal 30. It's got to add to equal 13. What do we pick? 10 and 3. I can reduce the one on the left, becomes x plus 5. The one on the right becomes 2x plus 3. Same answers we had? Oops, sorry. Okay, there is a little bit of guess and check to it. I think if you go with that Berry method, it's going to narrow down your guessing and checking and not trying to multiply numbers when you're trying to add them up. Let's walk through another one. Let's go 3p squared minus 7p minus 40. Common factors? No. So, using Berry method, I'm going to put 3p as the front for both of them. It's going to be reduced somehow, so I won't end up with something that would be 9p squared. It will simplify, assuming we do it correctly. I now go 3 and negative 40, so it's got to multiply to be negative 120, and add to be negative 7. Now, if it's multiplying to be a negative and adding to be a negative, what do I know about the two numbers? One's positive, one's negative. Which one's bigger? Okay, so I've got, really I'm looking for two numbers that multiply to 120 that are 7 apart. Okay, if you're not sure, you can always just start listing them out. You find one that works for you. Am I close yet? No. But if I took 4 and 30, I took 2 away from the 30 and put it on the 4, I'd have 8 and 15, right? Those 7 apart? Which one do I want to be negative? Good. So we're going to go plus 8 minus 15. (3p plus 8 stays). What's the second one become? Yep, p minus 5. If we kind of check with the, if we did the box method, I got an 8 and negative 5. So that would get me to 4, negative 40. 3p and p would get me 3p squared. And it's the 8p and negative 15p that combines to be negative 7p. All right, I'm going to give you 2 to work with so we can kind of work on this process. Yeah?
How did you go from 4 to 30 to 8 to 15?
I was just listing factors, and what I can do sometimes is if I took like, made this half and doubled this one, it's just moving a 2 in the factors over. Sometimes when you have a whole bunch that's quicker, you can always just go through and list them all. It's really just finding them. As numbers get bigger, you may need to make that list. Go run a lap. All right, let's go 4x squared minus 36x plus 81. And just do that one. No, we didn't. Three g to the 3g squared plus 20g plus 32. All right, 324 is a product, adds to negative 36. Any ideas? Negative 18 and what? Oh, I'm writing on the wrong one. Is that what you guys have?
Yeah.
Hey, it's a perfect square. How about that? All right. Now what? Reduce them?
Yes.
Okay. A note there. When you reduce using this Berry method, you're not factoring out a value. You've got to be careful with that. That's where I could see some confusion. That's why if you do GCF to start, it cleans it up. So we got 2x minus 9 and 2x minus 9, which is also 2x minus 9 squared. We'll talk a little bit more about the patterns that show up as we go further. But notice here we could almost predict that. Perfect square and perfect square. So I have that 4 and that 81. It leads to the 2 and the 9. It's not a difference of two squares like we looked at last week, where it's one's addition, one's subtraction, but there's some patterns that show up there. We'll get to those. Let's go over to the right. Multiplies to 96, adds to 20. What we got?
Eight
8 and 12. Okay, since they're both positive, we know it's got to be two positive numbers. The one on the left becomes g plus 4. One on the right, 3g plus 8. It's good at that point, go back, just make sure the outside value seems to fit. 3g gives me 3g squared. 4 and 8 would give me 32. It's like here, 2x and 2x gives me 4. Negative 9 gives me positive 81. Just making sure things were cleaned up correctly. Now the last one I want to go through is there. We got some different exponents than what we've had. But starting from the beginning, do we have a greatest common factor? 3, right? Okay, so 2a to the 6th, 21a to the 3rd, b, not 21, try 7, and minus 4b to the 4th. Now, is there any a's or b's that are in every term we could factor out? Because I noticed I got like a to the 6th and a to the 3rd. That's kind of weird for what we're doing. But can I factor anything out there? No? Well, let's get an idea to what this is going to become. Oops, I got ahead of myself. That should be a squared on the b. Or else this really is not going to work. Make those squareds. Sorry. All right. Predicting what the a's and b's are going to be. I'm not worried about the numbers yet. Predicting what the a's and b's, I'm pretty certain this is going to be a b and a b. Since this is b squared, I'm going to have that b as the last term. What's the a going to be? If it's a to the 6th here and a to the 3rd there. A to the 3rd for both. So we need to figure out where those coefficients go. Now, how that's different, let me jump back to the previous one. When I had something like this, g squared, the exponent became half, so it just became g and g. G to the sixth becomes, or a to the sixth becomes a to the third, a to the third. We're just taking half of it. We saw some a to the fourths yesterday. Yeah.
What about the b in the middle after a to the third? You just leave
That shows up because these are going to be b squared, and that's that diagonal in the box when you multiply them. When you worry about the exponents here, you look at the last term and the first term. These are just the combined terms. When we get to factors, I'll show you in the box we multiply. All right, let's put 2's here. Following the Berry method. Now I'm looking at multiplying to what? -8. Add to what? Right? Not to be confused with multiplying to 7 and adding to -8, which would be completely different. What numbers do you want to use if you multiply to -8, add to 7? 8 and -1. 8's bigger, it's positive, so we like that. So 8 and -1. The first one simplifies in our Berry method, and we get 3 times a cubed plus 4b, 2a cubed minus b. We added the extra layers with the exponents, but it still came down to using the factors. Even if you went back and looked at multiplying with the box, which again, I'm okay with. If this Berry method doesn't work for you, I need you to be able to factor, however that method may be. So if I started with 2a to the 6th plus 7a third b minus 4b squared, so I know I got to have an 2a, excuse me, 2a to the third and an a to the third. I'm going to have a b and a b here. So I'm thinking, how can I get -4? Well, I could do -2, +2. I could do -4, +1, or +1, -1, +4. Well, if I tried, let's go 4 here, -1 there. This becomes -ab to a to the third b. This becomes 8a to the third b, and it combines to give us our 7. So that a to the third is from those like terms. This is going to be a little bit more complex guess and check. If it works for you, use it. But that process that we've talked about, that Berry method, I think it's going to help, especially because we don't have to worry about that lead coefficient. Where that lead coefficient goes is the tough part we usually run into with factoring. So, we just went through and did all the evens. No, we didn't. We did the odds. So your assignment is 2 through 18 even. For 1.4. I sure hope I just did the odds.